But to be able to push that forward, going to the last piece of what we have been discussing, how we might be able to bring AI to this field. To be able to bring ChatGPT to this field, just few slides giving you a sense how ChatGPT is going to be a part of this, you need to know what is ChatGPT, first of all, having a good understanding about ChatGPT. I mean, you know what is AI. We know that, this is artificial intelligence. And the first type of AI is what we call ELIZA. Have you heard about ELIZA? Probably. Those who are old, it goes back to around 60s. And Mark, could you tell us what was ELIZA at that period of time? Okay, so that, anybody could tell us what was ELIZA at that period of time in 60s, 1960s? It was the first chatbot that you have been able to talk with it. So these are the sort of the interactions that you can have with that computer. In terms of, you can just, it was introducing itself and asking you what is your name and asking your problem, exactly like chat. But they have been using very basic initial computer. So they started the AI from 1960 something, okay? And then machine learning is a type of AI within that sort of structure. And then deep learning is something that is flourishing during the last 10 years, using artificial neural networks, right? Multi-layers neural networks that we call ANN. And that is deep learning, that is revolutionizing the field. And within deep learning, we have foundation models that you use a deep learning model and you use huge amount of data and that you train a model and then you just sell the trained model. And the trained model is called foundation model. And if you train your foundation model with text and language, it is called large language model. And ChatGPT is actually a type of foundation model that is pre-trained for language, okay? Now we have vision models that they can see things. We have audio models that they can make new songs from old artists and singers, right? And we also have science foundation models that are specifically designed in the field for science. For example, there are protein foundation models that are trained based on all the proteins that we have in the field, and then you can use that model and say, okay, this new sequence of amino acids, what would be the 3D structure of that sequence? This is called protein foundation. And there are already multiple protein foundation models that people are using. And there are some brain foundation models that are trained or pre-trained by brain data, like ChatGPT, but using brain data. And one of the most famous one in the field of MRI is called NeuroSTORM. It's a brand new thing that is introduced in 2025. And how it works, the initial models, traditional models, then having things like random forest support vector machines, things like that. And then deep learning models, these are the kind of the last 10 years, CCNN, things like that. And then brain foundation models, these are the first one from Stanford 2020, some of the new ones in 2023, and now many in 2025, and most of them are around EEG. Just few of them, they can do MRI, because training with MRI is harder. But specifically, NeuroSTORM is designed and trained with MRI data. And they train it using 9,000 hours of fMRI data. They train the entire model. The model is an open source model, so you can just have access to the model. And you can use the model. This is the structure of the model in terms of the databases that they put inside that model. 72,000 individualized fMRI data is in the model. 72,000 people. And they show that for different applications of machine learning methods, I do not have time to go to the details, but for those things, these new NeuroSTORM model, it outperforms all the models that are being designed before. In all those applications, it is functioning much better than them. And now they can also not only use fMRI data, they can have animal data, they can have DTI data, and they can just fuse those levels of data together, and we can use them in different applications, including personalized biomarker development. And now we can have what we call digital twin brains, in terms of they can scan my brain, use that foundation model that is already existing, and develop a digital version of my brain and say, okay, for Hamed, if we do a stimulation here, how that stimulation is going to change his brain function or the network of fMRI drug curie activity in his brain. And that is going to be the future of the field. And you can be a part of that future.